Hello everyone, Mr. Fawcett back here, and we are ready for another lesson dealing with angles. So we're going to talk about some more categories we can place angles into. We'll talk about some more angle relationships, and then in the second half of this video we'll really get to some of the application problems. So the first half will just be looking at what those relationships are, making sure we understand what constitutes each one, and then we'll start to apply them in video number 2. Before we get into anything new, let's do some review from previous lessons. And I'm going to have you answer questions 1 through 4. So as always, take the time to do this by pausing the video. Come back once you have answers for all 4. All right, so for number 1, we're just being asked to simplify the expression completely. So the only possible tricky thing in here is making sure we distribute this negative to both terms. So I get 90 minus x as well as minus 20. And then I get negative x plus 70. You could also just have 70 minus x. Either one of those would be acceptable. Okay, number 2, again, we're simplifying the expression, and again, we just need to distribute this negative sign. So I get 180 minus 3x plus 10, because I'm multiplying a negative to a negative, so I get a positive. So this leaves me with negative 3x plus 190. If you had it as 190 minus 3x, you're also receiving full credit. Numbers 3 and 4 give us an expression, and we have to turn that into an algebraic expression. So the first one says 4 more than twice a number. So 4 more should indicate we need to add 4. And twice a number is 2 times some number. We don't know what that number is, so we're going to call it x. You could call it c, you could call it w. You just need to have a variable. So 2 times a number, 2x, and we said 4 more than twice a number, so plus 4. 2x plus 4. If you had 4 plus 2x, that also is correct. Number 4 says 6 less than half a number. So 6 less means we're going to be subtracting, and half a number means you can think of this 2 ways. We are either multiplying the number by half, or we are dividing the number by 2. Again, we'll just use, well, you know what, let's use w here. So we have half a number, or w divided by 2 minus 6. You could also have 1/2 w. Again, that's the same thing as w divided by 2, and then still subtract 6. All right, let's look at some of our vocab for today. We are going to start off with adjacent angles. And adjacent angles are 2 angles that have a common vertex and share one side. You can think of adjacent angles as angles that are side by side. So if we come over here to our examples, we have a red angle here, angle number 1. It shares a side with angle number 2 as well as a vertex. So adjacent angles share a side and a vertex. Same thing if we come over here, we have our angle for number 2. And we have our angle 1. And again, they both share that vertex and they both share a side. Moving on to linear pairs. A linear pair is a pair of adjacent angles that form a line. So again, we could look at our example. We have angle 1, do that in red. And I have angle 2. But the special thing about linear pairs, they're adjacent angles, but they form a line. So together, right, the measure of both of those angles should add up to the measure of a straight angle, 180 degrees. Again, together they should add up to 180. And then we can come over here and we see, again, here's angle 3, here's angle 4, and they both share a vertex, they both share a side, and what makes them a linear pair, right, is that they form that line. So linear pairs are just a subcategory of adjacent angles. They're a specific type of adjacent angles. All right, vertical angles. Vertical angles are two opposite angles formed by two intersecting lines. You can think of vertical angles as forming an X, and we'll trace that on our example in a second. Vertical angles are congruent. When we start proofs, we will actually prove why this is true, but for now you can just take my word for it. So if I come over here and I show you what the vertical angles are, right? We have angle 1, and we have angle 2. Those are, oops, let's do something better than that. That's not even that better. Yeah, we're going to try that one more time. Little OCD about this. Getting it right. Okay. So vertical angles, and you can look on our diagram, right? They form that X shape. Now, vertical angles here are not just pick any two, right? They're specifically angle 1 and angle 2, or we have vertical angles 3 and 4. So vertical angles are not adjacent, right? They do not share a side. They share a vertex, but no sides, and they are directly across from one another. All right, let's move on to our last two. We have complementary angles. I assume that you've heard of complementary and supplementary, again, probably your middle school geometry section. But these are two angles whose measures have a sum of 90 degrees. So complementary, they both need to add to 90. Complementary angles always come in pairs. You don't call a single angle complementary. You call two angles that add to 90 degrees complementary. So we have one example here, right? This entire angle, let's do something that's easier to see. So the entire angle is a right angle because we have that little box, and it's being split into two smaller ones. So if the whole angle is 90, well, the two smaller ones will have to equal 90, which makes them complementary. Complementary angles do not have to be adjacent, though. So we have these two angles that are complementary, but they're not touching, and that's okay. The definition of complementary just means that there are two angles and their measurements add to 90. Complementary has nothing to do with the angle's position or orientation, just their measurement. Supplementary angles, the different characteristic is that these angles will have a sum of 180 degrees. So twice as much as complementary's sum. And linear pairs are always supplementary, right? They form a line, so they're always going to have a measure of 180 degrees, which would make them supplementary. Again, supplementary angles can be completely separate, or they can be adjacent. Or they could be vertical, right? They could be touching in a way where they only share a vertex, not any sides. So we talked about a couple different categories here. We talked about a first set of categories, the adjacent, linear, and vertical. And these all had to do with the angle's position or the angle's orientation, right? Adjacent, linear pair, and vertical. You can say some things about their measurements, like linear pairs always measure 180, but linear pairs have to be specifically set up right next to each other, right? They have to be adjacent and they have to form a line. Same thing with vertical. They have to be opposite one another. They have to share the same vertex. And adjacent angles, they share a side and a vertex. So these first three categories deal with the angle's orientation or the angle's position. If we come down here to complementary and supplementary, these categories strictly deal with the measurements of the angles. So again, it doesn't matter what their position or orientation are. They can be completely separate. They can be turned. They can be together. It only deals with the measurements. So that's going to fill in these two blanks here. Adjacent angles, linear pairs, and vertical angles are special because of how they are oriented in relationship to each other. Or you could say positioned. Complementary and supplementary are special because of their relationship between their angle measures. Okay, so let's jump into some problems here. We're going to categorize some angles. So there's 1, 2, 3, and 4. And again, you're going to try these before you look at the answers and explanations. You just need to put them into the best category. All right, so they may fall into two categories, but choose the one that's the best, the one that's the most descriptive, and then come back and see how your answers hold up. Okay, so for number 1, the angles are not positioned in any way that would give us a linear pair, adjacent, or vertical angles, but they do add to 180, right? 120 plus 60 is going to be equal to 180. So we can say that these two angles are supplementary. Yeah, we are going to write the whole word out. And then because their measurements sum, or you can say add to 180 degrees. On to number 2. So we have angles AOD and angle DOB. So we are looking at AOD, which we have right here, and DOB, which we have right here. So these angles are connected, and we need to figure out the way that they're connected, right? They share this common vertex at O, and they share this side OD, the side right here. If we go back up to our charts and find the right category, these angles are considered adjacent, but they're also considered linear pairs, right? So we've got to make the best decision here. Is it best to call these adjacent, or is it best to call these linear pairs? Well, if we think about a little Venn diagram, right? I think that's what they call these. Adjacent angles is the large category, right? And then the linear pairs is a smaller subset of adjacent angles. So calling them adjacent is correct, but it's not as specific as we could be. And we want to be super specific. Super specific. We just want to be specific. So we're going to call these angles linear pairs. That's the best choice because they are adjacent angles that form a line. That's what a linear pair is, two adjacent angles that form a line. If you're still wondering why adjacent is not the best answer here, think about if you were asking your cousin what sport they played, right? Maybe you hadn't seen your cousin in a while and you were trying to figure out what's new with their life, and you said, hey, we'll call them Max. And you said, hey, Max, what sport have you been playing recently? And they said, I just ruined my analogy. say you just ask Max what he was up to recently. And you're like, hey, Max, do you do any activities after school? And he says, I sure do. I play sports. Well, would it be better for him to tell you he plays a sport, or would it be better for him to tell you he plays soccer or he plays basketball, right? Telling you he plays a sport is correct, but it's not as specific. It doesn't tell the whole story. It gives you much more information if he tells you what specific sport he plays. So this is a situation we're kind of in, right? You can say that they're adjacent angles, but if we know what specific type of adjacent angles they are, if we know that they're a linear pair, then we might as well say linear pair because it gives the reader more information. All right, let's move on to 3 and 4, and then we're going to be done with the first part of this video. So here we have COA. So we have this angle in purple, and we have BOD. So right away we notice that they share this vertex at O, and they form that letter shape, right? They form an X. So this makes these vertical angles. Because they are opposite angles. Opposite angles formed by two, it's not the right two intersecting lines. On to number 4, we have angle CBD, and we have angle DBA. So there's actually, there's a couple different ways you could go here. You could talk about the measurements of these angles, right? We know that both of these angles add to 90, so we could say that they're complementary. Now that strictly deals with just their measurements. It doesn't tell the reader that they're also connected in a way that makes them adjacent. So I would actually accept 2 answers here. I would accept a complementary answer if you said that they sum to 90 degrees, or I would accept a adjacent answer. So you could say that they're adjacent angles because they share a side and a vertex. Okay, this is really the only one out of the 4 where both options tell us 2 different things, right? In number 2, when we say they're a linear pair, that also tells us that they're adjacent. But down here, if we say that they're adjacent, it doesn't also tell us that they're complementary. So again, 2 possible answers here. You can say complementary, or you could say adjacent if you only had to pick one, and then you would need to provide the correct justification for each one. Okay, that is it for today, or for this video rather. We'll come back for a part 2 where we work out some more practice problems. As always, enjoy the rest of the day, and I look forward to seeing you next time.